Hello. These notes are about translating a function. So what I have open now is a program called Graph. It's a free program. You can download it and play with it yourself if you want. And we're going to investigate how to translate or shift a function. Translating is really just another word for shifting a function. So let's graph a function. Let's graph f of x equals x squared here. We know that that is a parabola, and I want to know, how do I shift this around the coordinate plane? So let's investigate. Let me graph another parabola. Let me graph this one as x minus 2, the quantity squared. Oops, I need to make that squared. There we go. So before I hit enter to graph this, let's make it a different color. Notice it's x minus 2 the quantity squared. It's still a quadratic function, but I just did something to the x coordinate there. Notice it's the same shape, same graph, it's just shifted 2 units over to the right. So we subtracted 2 from the x coordinate, and it shifted 2 units to the right. So what do you think is going to happen if we add 2 to x before we square it? It's the same family, still a parabola. Let's make it a different color. If you guessed that it would go 2 units to the left, you'd be correct. So, this was our original. That was shifted 2 units to the right, shifted 2 units to the left. We subtracted 2 from the x-coordinate. We added 2 to the x-coordinate before we squared it. That's really what happens to the function. What about this? What if I don't do anything to the x-coordinate, but I add 4 on the end? So I didn't do the plus 4 to the x. I did it to the x squared after we squared the x. This time it went up 4 units. Well, what do you think is going to happen if instead of adding 4 to x squared, we subtract 4 from x squared? Here it moved down 4 units. So this is how we can see a more vertical shift. Instead of adding or subtracting a number to the x value in our equation, we're adding and subtracting something all the way at the end of the equation. So here's our original. Here's shifting up 4, x squared plus 4. And here's shifting down 4, x squared minus 4. You might find it a little strange that we added 2, it went to the left, and when we added 4, it went up. That's because of the nature of where the number is in the equation. So it takes a little bit getting used to, but when we add something to the x-coordinate, it does move it left. When we add something to the y-coordinate, well, to the end of the whole function, it is shifting it up. So it might be a little counterintuitive. You might want to play around with it to really cement this in your mind, but that is how that works. So let's summarize what we just talked about. If we were given f of x, let's make this a little smaller here. If we had f of x minus some value, this would shift our function some number of units in the horizontal direction. For example, f of x minus 2 shifts f of x 2 units to the right. F of x plus 2 shifts f of x 2 units to the left. They're both horizontal shifts, but we have to pay attention if it's positive or negative if we're moving left or right. What about moving up or down? Now we're adding a value on the outside of our function. This will create a vertical shift like we saw. Here's an example. F of x plus 4 shifts f of x 4 units up. F of x minus 4 will shift f of x 4 units down. So that plus some number on the end will shift it up. The minus some number on the end will shift it down. And that's really a summary for how you can shift any function left or right or up or down. You can add or subtract something to the x-coordinate, or add and subtract something outside of the function. Maybe you don't believe me, because all of these investigations that we've done have been with a parabola. So let's try this with a different function. How about something you might not have even seen before, 2 to the x power. That's called an exponential function, and it looks like that. That's 2 to the x. So let's say I would want to shift this 3 units to the left. According to my summary, we would want to add 3 to the x-coordinate. So the x-coordinate here shows up in the exponent. So instead of raising 2 to the x power, I'm going to raise it to 2 to the x plus 3 power. Notice that's in parentheses because I wanted to add 3 to the x, which is still in the exponent. So if my summary is correct, that will shift that 3 units left because I added 3 to the x. And indeed it does. You might think that the shape looks a little bit different, but it's really the same exact shape. We can just see more of it because we shifted it to the left. So it would really have the same steepness over here. We just can't see it in our original. Let's do something really crazy. Are we allowed to apply more than one shift at a time? Of course we can. Let's take our exponential, and let's this time make it go to the right, 2 to the x minus 5. And let's say I also want to shift it down 7 units. Minus 7, I'm going to put on the end. Notice the x minus 5 is all up in the exponent, and the minus 7 is after the whole function. So that should shift it 5 units to the right and 7 units down. Let's see if it did. It did. 5 units to the right and 7 units down. Again, you might think the shape looks a little different, but it's really the same exact shape. It's the same family, 2 to the x. It's just that we can see more of it because of the shift. So we can apply these horizontal shifts, these vertical shifts. We can do more than one at a time. And notice it's not changing the shape of the function. It's just changing where the function is. What about, this is a little bit beyond translating, this is more of transformations, but what if we, actually let's not look at these for now. What if we multiplied a function by something? Let's go back to our x squared example. And what if I multiplied x squared by 2? What do you think that's going to do? I didn't add or subtract anything to the x coordinate or afterwards, so it's not going to shift it at all. But that 2 does change the shape of it. Remember, this was our original x squared. Well, it's got the same shape, but notice it's a little bit narrower. It's actually stretched it. Can you imagine kind of grabbing the ends of the orange graph and stretching it till you get the blue graph? You can kind of see that all the way up. I can shift this all the way up. The blue graph is narrower than the orange graph. So multiplying by a value actually stretches it, or we can shrink it if we multiply by something less than 1. What if I did 0.5 x squared? Yellow's not good. How about red? So notice the red graph kind of shrunk it a little bit down. We kind of squished it down. So that's another nice thing to note. We can multiply by some number on the outside of our function, and that will also transform it. It's not the same as a translation. It's not a shift, but it is something that we can do to functions to make them look a little different while still keeping them in the same family. They're all quadratics. They just have a different lead coefficient. Good luck with transforming.